Hi, welcome to this video. In this video, we're going to go through question 3 of the 2014 paper. It will cover vertical projectile motion. So let's get into it. A ball A is thrown vertically upward from a height h with a speed of 15 meters per second. And at the same instant, a second ball B is dropped from the same height as the ball A as shown in the diagram below. Both balls undergo free fall and eventually hit the ground. So we got ball A thrown upwards, ball B dropped downwards. 3.1 says explain the term free fall. So free fall is a motion which the only force acting on an object is gravitational force. The only definitions you need to know for vertical projectile motion is one for projectile, which is an object which has been given an initial velocity and then it moves under the influence of the gravitational force only. And free fall, which is the motion during which the only force acting on an object is gravitational force. Those are the only definitions you need to know for vertical projectile motion in one dimension. Let's go to 3.2. In 3.2, they ask us to calculate the time it takes for ball A to return to its starting point. So ball A is thrown upwards, it gets to rest at that point, and then it drops. So they want to know what the time is when it comes back to this point here, the starting position. That means delta x is 0, and our time is what we're looking for. What I would like to assume is that it takes twice as time to get to the starting position as it would to get to the top. So the time it takes to get to the top will be the same time it takes to get back to the starting position. So I would just simply use the initial, as stated there, is 5 meters per second, and know that the final, when it gets to the top, is 0 meters per second. And that should be enough for me to get the time it takes to get to the top, and then I'll just multiply t total as 2 times the time it took to get to the top. So what formula can we use to get that answer? So in our formula sheet, under equations of motion, you need to look for one that involves getting time and has initial, final. We know acceleration, so we can use this one. Let's jump into that one and see if we can calculate the time. So back to our question of these values. We'll be using the first equation, which is final velocity equals the initial velocity plus acceleration times change in time. And we got final, we have initial, we know acceleration is equal to gravitation, and assuming up as positive, that means our gravitational acceleration will be negative 9.8 meters per second squared. And therefore we're just left with delta t to get. So if we make delta t the subject of the formula, we'll have delta t equals, so we're moving, okay, let's take this step by step. If we move the initial velocity to the other side of the formula, we'll be left with acceleration times delta t, and we'll have final velocity minus initial velocity, and therefore if we divide both sides by a, we'll have final velocity minus initial velocity over acceleration, and therefore we can plug everything into the formula. So final velocity is 0, our initial velocity is 50, and our acceleration is negative 9.8. If we punch that into our calculator, we'll get 1.53 seconds. So we're not finished yet. The total time is 2 times that 1.53 seconds, which is 3.06 seconds. That's our final answer. Let's go to the next question. The next question says, calculate the distance between ball A and ball B when ball A is at its maximum height. So distance between ball A and ball B when A is at its maximum height, which means ball A will take time to come up here and B will drop somewhere there, and they want the distance. Let me just write it down. They want the distance between the two. So B will be somewhere there maybe, and A will be somewhere there. It will be up here actually. That's where it will reach its maximum height, and we need to find delta x. So we're going to divide this into two problems and add them together. The problem here will be, we're going to calculate delta x for A, and then we're also going to calculate delta x for B, and we'll add them up to get the total distance between the two of them. So yeah, let's get into that. That's question 3.3. Here's 3.3. I'm going to use the time we used in the previous questions, because we know at 1.53 seconds that A reaches its maximum height. So our delta t will be 1.53 seconds. That'll be very important, because that means the time taken for the distances, for both the distances, will be 1.53 seconds. Let's see what formula we can use to determine what answer we can get. So we need the ones that have delta x in them. That's this one, this one, this one, because we are calculating distance and we want to use time in this case. So this one is out of the question, and we're left with these two. And these two, we have one that includes final velocity, which we don't have, especially in the case of the ball that is dropped. We don't know what velocity it will get in that certain time. If we knew, we'd use this, but we don't. So we have one that assumes initial velocity. We know the initial velocity of both, and we know the time it will take for both, and we know the gravitational acceleration. For free-falling objects of projectile motion will always be gravity. So let's go back to our question and use this formula. So for 3.3, going to use the first formula, which is delta x is equal to initial velocity delta t plus half a delta t squared. So let's start with delta x of a. The initial velocity in A's case is 15 meters per second. The time taken will be 1.53 seconds. And then we have acceleration. Remember, we took up as positive. Therefore, gravitational acceleration will be acting in the negative direction. So negative 9.8. And then t squared will be 1.53 squared. We punch that into our calculator. We get 11.48 meters for delta x of a. So let's calculate delta x of b. So in B's case, we have a ball that's dropped, which means our initial velocity is 0, which means we can negate this part because 0 times anything, it will be 0. Therefore, we'll be dealing with the second part of the formula, which is half, negative 9.8 for A, and 1.53 for T squared. Punch that into the calculator and we get minus 11.48 meters. Now remember, this minus just indicates that this is below a certain point, which means our point of reference will be here. The top part is 0 in our case, which means that ball A goes 11.48 meters upwards, and ball B goes 11.482 meters downwards, which means the total distance of the two is delta x, which is 11.4 for A and 11.48 for B, which gives us, let's see, 6, 9, 22. 22.96 meters. Let's go to the next question. The next question, 3.4, says, sketch a velocity time graph in the answer book for the motion of ball A from the time it is projected until it hits the ground. Clearly show the following on your graph: the initial velocity, the time it takes to reach the maximum height, the time it takes to return to the starting point. So it's a velocity time graph. We'll have velocity on the y-axis, time on the x-axis, and it's for ball A. Ball A is thrown upwards. We take up as positive. It gets to rest and then it moves downwards. So downwards being negative. Upwards to 0 and then downwards in the negative direction. Sounds simple. Let's go and draw it, shall we? So 3.4, let's draw our y and x axis. We'll need both positive and negative. It's important to keep that in mind. So because we need both positive positive and negative, we will need to have a 0 point somewhere in the middle of a graph. So on one side we have velocity. I think you can just indicate that as v, units being meters per second. And here you'll have time, which you can just indicate as t, which will be in seconds. And this will be our 0 point. Now the ball A, so it starts at 15 meters per second and it drops all the way down like so. It has to pass the 0 line because at this point it reaches its maximum height, and at another point it reaches the other point that we need to have noted, which is the time it takes to return to the starting position. We calculated this time it takes to get to the starting position at 3.2. We saw that answer was 3,06. So we have those values, 3,06, and the time it took to get to the maximum height was half that, which was 1.53 seconds. So you have those values, and basically this is your final answer. I hope this helps with the vertical projectile motion. Hopefully in time we'll have a more detailed explanation of everything you need to know for vertical projectile motion. But for now, this is how to answer question 3 from the 2014 paper. Hope you do well in your exams. Goodbye.